That's Matt. He's in the video too.
Alright, so science of momentum. Mostly what I'm going to be talking about is collisions, and would have been talking about these things and explaining them to you with Matt, but he had to do something stupid like baseball! Or work, I don't really know. If you think of momentum as an equation, you start with P for momentum equal to mass times velocity. You have an object that's mass is 15 kilograms, and it's going at a velocity of 2 meters per second. The momentum will be 30 kilograms times meter per second. But if you have a heavier object, it's going to have more momentum because it has a higher mass. So if it's, say, 30 kilograms and it's going the same speed, 2 meters per second, then it's going to be 60 kilograms times meters per second. And yeah. But then if you need to find the change in momentum, so delta P, then it's going to be mass times the final velocity minus the initial velocity. Collisions deal mostly with the conservation of momentum. And say you have two equal masses, mass 1 and mass 2, and they're coming at each other at the same speed. They're going to hit each other, and as soon as they collide, as long as they're not sticking together, I think that's elastic, right? Yeah, cool. All of the momentum from mass 1 gets transferred into mass 2, and all the momentum from mass 2 gets transferred into mass 1, and they both come back apart at the exact same speed. So, pretty crazy. Pretty crazy stuff. You got two objects, one standing still, one's coming at the other one. All the momentum from mass 1 gets transferred into mass 2, and mass 1 stays here. Say you've got two objects of equal mass that are going at two different speeds. Mass 2 is going slower than mass 1, which is going pretty darn fast. Twice as fast as mass 2. If you just say the velocity equals 1 of mass 2, it's going this fast, and the velocity of mass 1 is 2, and when they collide, the extra momentum from mass 1 is going to be transferred to mass 2, and mass 2 is then in turn going to be going twice as fast as mass 1. The final velocity of mass 2 is equal to the initial velocity of mass 1, and the final velocity of mass 1 is equal to the initial velocity of mass 2. Now, there's also a relationship between force and momentum. Momentum measures the motion content, if you will, of an object, which is based on the mass of the object times its velocity. Force is the push or pull that's applied to an object to change its momentum. Second law of motion defines force as mass times acceleration, or mass times velocity over time. And if you take that equation and set it equal to momentum divided by time, then multiply either side of the equation by time. That is another equation for momentum. So say this giant Christmas ornament is thrown, it has a force applied to it, and when I catch it, it'll have greater momentum if I catch it just straight like that, because the force is applied to my hand in this amount of time. But say it's thrown and I catch it here and cushion the catch, then the force is applied over a longer amount of time, the force is great and it doesn't hurt my hands as much if it were, you know, heavier. In contrast to the elastic collision, in which both masses travel at the same velocity and are equal in mass and go apart perfectly, if you have two objects that are of equal mass and are of equal velocities, but it ends up being an inelastic collision, say there's two cars and they're of equal mass and they're traveling at the same velocity, and they decide, hey, let's drive at each other and hit each other's face. They're getting their engines revved, they're getting all excited. When each car finally ends up colliding with the other, they're gonna stick together and just stay put. They're not gonna move. Things that can happen when you're dealing with elastic collisions of unequal masses. Lighter mass is gonna be stationary, and the heavier mass is gonna come at the lighter mass at an immense velocity. Then, when they end up colliding, the smaller mass will fly really far away because the momentum needs to be conserved. Say the heavier mass collides with the lighter mass with a velocity of 1, and the lighter mass is half as heavy as the heavier mass. Then the lighter mass will be going twice as fast as the heavier mass because the momentum has to be equal in the end. Say you have two unequal masses that collide with one another. You have a heavier mass and you have a lighter mass. When they finally meet, because the lighter mass isn't as heavy, it will not have as great a momentum. So when it collides with the heavier mass will break away from the collision at a smaller velocity. And because the heavier mass has a greater momentum, when it collides with the lighter mass will break away with a greater velocity. Now, if you switch that around and you have the lighter velocity that collides with the stationary heavier velocity, then when the two collide, basically the opposite will be true. Because the heavier object has a greater mass, when it collides with the lighter object, the heavier object will come away at a slower velocity, or at a fairly slow velocity, and the lighter object will become very, 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 very slow.
Petro Viljema and me.